Hi, my name is Reza. I'm the assessor and tutor for surveying courses at Finchley College. In this video, what I want to show you is how an automatic level, or a level in those days, it wasn't automatic, was being used for surveying and setting out. It's the original surveying equipment that was manufactured, the very first. It didn't look anything like this. It looked more like a telescope than this. But its job was essentially surveying and setting out. Wasn't done very accurately, but good enough. Now, the way it used to work is that in here you have a line, and you've got angles starting from 0, then it goes to 10, 20, and it goes all the way back to 360. You could align it with 0 degrees, and then you can turn this angle as well to bring it in line. So you can sight to your target to where you want to be 0. Then you turn this angle and bring it to 0 to line up. And then as you point and turn, you can read the angle on the screen. I can show you with this one, with the other one here, that you've got these angles in here, and you can turn this base and rotate the angles until you get 0 degrees. And once the 0 is pointing towards where you're sighting, that's said the instrument is set for the angle. Then as you turn, you read the angle. Now, for surveying, what we need is two things. We need angle and we need distance. So I explained to you roughly on a triangle how it works. I'll move this away a bit. On a simple triangle, this angle alpha, sine of alpha, is this length opposite over the hypotenuse. Cos of alpha is the adjacent over the hypotenuse, and tangent of alpha is opposite over adjacent. So I can rewrite this formula in the term of difference in easting and difference in northing. So therefore, difference in easting, i.e. this length, this is the triangle is a Greek symbol for distance. Difference in easting will be the sine of this angle times this distance. And difference in northing, which is that length, will be cos of this angle times this distance. So when you do surveying, if I know the angle, if I know the distance, I can calculate opposite, adjacent, and then the coordinate for point 2 will be the coordinate of point 1 plus difference in easting and difference in northing. So if difference in easting is plus, that point is on your right. If difference in easting is minus, that point is on your left. If difference in northing is plus or minus, it's plus is to in front of you, if it's minus, it will be behind you. So what they used to do is to set it to 0, sight to a target. You can put a mark on the wall and set it to 0 degrees. And then an assistant is holding a staff. You sight to the staff, and you can read the angle on the screen. Now, to measure distance, when we look through the screen, we see this crosshair. We've got the main line in the middle is for reading levels. And I've got two short lines, top and bottom. We call it the Stadia lines. If I subtract the top from the bottom, multiply by 100, say it's 200 millimeters. 200 millimeters times 100 will be 20,000 millimeters. And 20,000 millimeters is 20 meters. If we do in meters, 0.2 times 100 will be 20, and that's 20 meters. So I can simply, when I look at the staff, I can read the top, subtract from the bottom, and I can multiply by 100, calculate distance. So now I have my distance, I have my angle, which I can read on the screen. Sine of that angle times distance gives me difference in easting. Cos of the angle times distance gives me difference in northing. I can add it, so I can give this total level a coordinate, say let it be 200, 500, and therefore the coordinate for that, if this was 20 degrees at 20 meters, will be sine of 20 times 20 meters will be 6.8. So that length will be 6.840. And cos of 20, if you do go to a calculator, go to your simple calculator and do cos 20 times 20 meters and that will give you 18.793. So you just simply do cos times the distance, that will give you that, and then you will add it to the nosing of the first point, and you get a coordinate. So we can calculate coordinate of the points we survey with an automatic level by reading the angle on the screen, by calculating the stadia. So if I turn this one here so you can see the screen. On this screen, you can see the top stadia and the bottom. So when you look, you can see top stadia, bottom stadia. In this case, that's about 210 millimeters. 100, 200, 5 mil extra, 5 mil there. 210, that's 20 meters. So we can calculate the distance by using the stadia lines. And that's how we used to use, we don't use it anymore, but if you have to, you can. If, for example, you go, total station is dead, it's not working, or if you go, for example, to developing countries where the accuracy is not like in here to 2 mil, 5 mil, 100 mil is good enough for me, you can use that for setting out and surveying. It's cheap equipment and it does the job, and it doesn't need a battery, it doesn't need anything, it never runs out, it always works 24 hours a day. It's the best equipment to use for approximate rough equipment. Now I'll tell you what the rough means. If this angle was 1 second, this distance was 100 meters, that opposite will be half a millimeter. So that's half a millimeter. If that was 1 second, it was 100 meters. If that was 30 seconds in 100 meters, that length will be 15 millimeters. Now with the automatic level, I can only read to the nearest half a degree. So if it's half a degree, 30 minutes would be 1,800 seconds. In 100 meters, that would be 900 millimeters. So that means the accuracy as I read through this is only to plus or minus a meter, 900 mil to a meter. Now that's too much, but that's over 100 meters. If the distance was 10 meters away from me, that would only be 90 mil, plus or minus 90 mil. And plus or minus 90 mil is good enough to mark 2 points on the ground with the given coordinates or sub-coordinates, and then use a tape 3, 4, 5 to set it out more accurately. So if that plot of flat, for example, is anywhere within the land, it's fine. So you can use this to either set out or survey with given coordinates. Now to set it out to that point, if you had 2 points you wanted to set it out, you can calculate what this angle should be. So then I know this coordinate, I subtract from this coordinate, I can calculate difference in easting and difference in northing. Using this formula, I can calculate arc tan of this over this, will give me the alpha. So I can calculate what the angle should be if I want this coordinate. And therefore then I can simply turn it to that angle. I can calculate distance using the distance formula. I'll show you the distance formula. The distance formula is distance is difference in easting squared plus difference in northing squared. So if I square that and square that to square root, I can calculate distance. So therefore you can use this for setting out. You know the coordinate of you've given it your own coordinate, you know the coordinate of the point you want to set out. You can calculate the angle and distance, turn the angle and work out the distance from here, and then you can do setting out. I hope you enjoyed the video understanding how it works. And the other thing is that when you get they always come in the box. In the box they always come with a plumb bob, and the purpose of the plumb bob is to set it up on a given point. So you can mark on the ground, set up on it, and do your surveying and setting out. I hope you enjoyed the video. I hope you subscribe to Finchley College YouTube for more videos. Thank you very much.